Hello everyone and welcome back to the Beta YouTube channel. So last day we concluded our discussion of motion using by distance and displacement. So I promised that I would make a video on vectors. What are vectors? How do you define a vector? How do you represent a vector? So this is that video, and then we are going to go on to some technical terms like distance, like speed, velocity, and then we are going to go to the equations of motion and the graphical interpretation of motion, graphical representation of motion, and reading into graphs. Okay, so what is a vector? There are some quantities in nature which require both magnitude and direction to be specific. For example, if I tell you about force, okay, then let's say I apply a force of 3 units on a certain body. Let's say a body is there, this is the floor, and let's say I apply a force of 3 units. But you have to tell me in which direction I am applying the force, because if I apply the force from this direction, the body is expected to move in this direction. If I apply a force in this direction, then the body is expected to move in this direction. If I apply a force from top, and this is the floor, then the body is not expected to move. And if I apply a force from the bottom, then the body is expected to move upwards. So basically you could not predict the movement of the body due to the force if you were not given the correct direction of the force. So the direction of the force was very valuable in this case. So force requires both magnitude and direction in order to be specified. Okay, but for example distance, or for example let's say time doesn't require a direction. Nobody asks you what is the direction of time. Okay, nobody asks you what is the direction of distance. Okay, so distance, time, mass, these are something which only needs magnitude or magnitude to be determined. Okay, for example speed, for example mass. No one if someone asks you what is your mass, for example you say 3 kg. If you say 3 kg, no one will ask you 3 kg in which direction. Okay, but if you say weight, then weight, my friend, is a vector quantity, and we are going to talk about the difference between mass and weight in a later video. Okay, so mass is something which is direction independent. You do not need to specify in which direction you are weighing. Your mass is 3 kg. Your mass is 3 kg in every direction. Okay, so these quantities which require only magnitude to be specified are known as scalars, quantities which we have been dealing with since our childhood, and these quantities which need both magnitude and direction is vector. Some other examples of vectors are displacement, something about which we have talked about in the last video. We have introduced in the last video, and we are also going to talk about it further. Something which you will learn: velocity, which is the rate of change of displacement. Acceleration is also a vector quantity. Torque is a vector quantity. You will understand what is torque when you go up to 11, 12 standards, and there are many more. Okay, and in case of scalars also there are many more. Time is a very fundamental example which I must give. So time. There are some quantities which behave both as scalars and vectors depending upon the situation. Area is one of the examples. Area is a scalar as well as a vector in some situations. Now don't ask me at this stage when is area scalar, when is area vector. You need high mathematics and complex physics to understand when is area scalar, when is area vector. You are going to study this in 12th standard. Okay, you are going to study that in 12th standards, that area behaves as a scalar and a vector. And apart from these, just for your extra information, there are certain quantities which are known as tensors. Okay, they are known as tensors. Example is moment of inertia. Okay, again these are examples, these are the meaning of these. You must not worry about these right now. You don't need it until you go to 11th standard. And torque, again something which you need not worry about right now because you need in 11th standard, and this is 12th standard thing. So just for your extra information I am telling you these things. So now we have an idea of what is a vector, something which needs both magnitude and direction to be specified properly. Okay, so now let me tell you how to represent a vector.